In this question, it says a man is standing on the deck of a ship which is 10-meter high above the water level. So let's first make the level of water. Let's say assume this to be the level of water, and he's standing on the deck of the ship, and which deck of the ship is given as 10-meter above the lake of the water. So let's say this is the top of the deck, say A being the top of the deck, AB, and say BC is the surface of the water. So it says further that he observes the angle of elevation of the top of the hill, which is 60 degree. So let's make a hill first. I'm making a hill that is from C, you will produce it above. Let's say D being the top of the hill and C being its base. The angle of elevation. So in order to make an angle of elevation, we must make a horizontal. So let's say first make an horizontal here. This I made the horizontal. And the angle of elevations, which is from this point to the top of the hill, is found to be 60 degree. So this being the angle of elevation, which is given as 60 degree. Further, it says that, and the angle of depression is 30 degree. That means from the same point, this time the angle of depression that is made is this angle of depression from the same point. That means we'll start from A only and then join C. That will give you the angle of depression. So this is the angle of depression, and this is found to be 30 degree. Let's write this point as say M. This AB, which is given 10 meter. So therefore even CM will also become 10 meter. What we have to find is the height of the hill. So the height of the hill, as you can see from the figure, we have to get the length of this, that is DC. As it's very clear that DC can be obtained by adding DM and CM. So we already know the length of CM. What we need to get is the length of DM, right? This being 90 degree, this being 90 degree. So according to the properties of parallelogram, we can say that the length of AM will be same as BC. And therefore, first we are going to get the length of BC. BC will be same as AM. Once we get the length of AM using trigonometric ratios, we can get the length of DM. So let's start with any right angle triangle. As of now, we can take with triangle ABC and we'll apply. Okay, one more thing, if this angle is 30 degree by alternate interior angle, this will be 30 degrees. So we'll apply tan 30, which is perpendicular over base. Perpendicular is AB and the base is BC. Tan 30, whose value is 1 by root 3. So I replaced with 1 by root 3. AB, which is given here 10 meter in the figure, and BC is what we are looking for. So by cross multiplication, BC comes out to be 10 root 3 meter. Now, once we get the length of BC, I can say that BC is same as AM. That means AM will also be equal to 10 root 3 meter. I mentioned here BC is same as AM. Now, once we get the length of AM, we'll apply same trigonometric ratio in the other triangle. Now I'm taking the other triangle. This time I'm taking the triangle ADM, and we'll apply tan 60. Tan 60, which is perpendicular, that is DM over the base is AM. Placing tan 60 as root 3 DM, which is what we are looking for, and AM, which is 10 root 3. So by cross multiplication, it will be 10 root 3 into root 3, which is 10 into 3, that is 30 meter. Now, once we get the length of DM, this being 10 root 30 meter, we have to get the length of DC. So clearly DC, which I told you, is DM plus CM. DM, which is given, which we have calculated DM here from here, that is 30, and CM, which is given as 10. So therefore this comes out to be 40 meter. And that is what our final answer for this question.